Hi everyone, my name is Marius. I'm a QA engineer. Thank you for coming to the event tonight. I'm going to talk about testing critical systems. So let's start. First of all, a quick summary. What the presentation will be about. I'll start with a brief introduction about my background. Then I'll provide a definition for critical systems. I'll talk a bit about the QA role in the development lifecycle, and that will be followed by the main point of the presentation, which is having multiple testing environments when you do your pre-production testing. And then I'm also going to talk about limitations of this approach, and at the end we'll have a Q&A session. So let's dive right in. I originally come from Romania. I came to Japan back in 2023. I have past experience in embedded systems and robotics, and currently I'm a QA engineer at KOMOJU. And KOMOJU is a payment service provider in Japan. It has over 65 payment methods, both for the domestic market and for international markets. The onboarding process for new merchants is completely online, so you don't need a fax machine to apply. That's cool. We also provide fraud detection services available at no extra cost. And for example, if you ever bought games on Steam Japan or Steam Korea, your payment was very likely processed by KOMOJU. And as you can imagine, we have a lot of features to test. And I want to define critical systems first. Basically, they are defined by these two characteristics. First of all, production bugs are really expensive. Second of all, the reaction time for fixing or mitigating a production bug is very limited. And just to give you an idea, a few years ago, I was in Finland. I was working on a project with autonomous drones. The objective was for the drone to autonomously land on a ship out at sea. And on one of our testing days, the drone took off from the shore. It flew for a few minutes, and then all of a sudden, it lost its GPS localization and crashed into the sea 20 seconds later. Unfortunately, there was not enough time to switch to manual mode, and we lost the drone, and we lost a lot of confidence that day. And I don't want you to think that this is limited only to autonomous drones, aviation industry, or autonomous vehicles and so on. For example, if you're a payment service provider and you have a Black Friday sale, then you have to deal with hundreds of payments each minute, and every minute that your system is down will cost a lot of money, which will have a tremendous negative effect on your business. So the rest of the presentation will be how we can minimize the probability of production bugs happening, and then even when they happen, how can we deal with them effectively. And before talking about testing itself, I want to emphasize that quality assurance is not only about the testing phase in a project. It's very important for the QA team to be to take part in the planning phase, design, up to release, and also post-release. And this approach has a number of advantages. For example, if the QA team is involved during the whole development of the project, then the QA team members will understand the architecture of the system and will be able to come up with better test case designs. Also, the QA team is often the first one to detect issues in pre-production systems. So if they already are familiar with the architecture, they are able to do the first phase of debugging and then provide valuable information to the developers so that they can fix the feature, they can fix the bug quicker. And also, post-release, if there are any production bugs, QA will be able to understand why that happened and how to improve the testing in the future. And now, again, before starting testing, I'm going to talk about this old standard from the aviation industry. Basically, all pilots, before they take off, they have to go through a boarding checklist. And the idea is we can do the same. For example, in the planning phase, a project manager can identify risks before the architect even starts to design the system. The developers can also identify risks while writing the code during development before QA starts. And also, as a QA, it's important to be able to identify the risks. For example, when you're testing, we're going to talk about testing in production later. So if you're not careful with the test setup you're going to do, there might be real users affected by your test, and we want to prevent that. And for example, some of these Boeing checks can be automated. If you're a developer, you can use stuff like linting or status code analysis to analyze your code even before making your PR. One more very common situation, for example, when you do the test setup, maybe you are missing an environment variable as a QA test engineer, and then you have to go through a lot of silent errors and false positive to understand that you're missing something crucial. So it's better to do that boring check in advance, automate it, and then make sure it doesn't happen. Also, maybe some of you are familiar with this test distribution. The idea is that you write a lot of unit tests because they're fast, or you try to limit the number of integration tests and E2E tests because they are quite costly. They take a lot of time to run. They're hard to debug. The problem is with this approach is not necessarily the number of tests you have or the distribution. It's that you're probably using only one testing environment. For example, at KOMOJU, we have to deal with upstream payment gateways, basically gateways that move money from one account to another. And some of these services don't even have a staging environment. So we have to write the implementation for communicating with the gateway and then just test it in production. That uses real money, so it's risky, and we have to deal with that. Also, if you're interested in writing load tests, you have to speed up an environment that has performance comparable to your production environment. Otherwise, the load test wouldn't make any sense on just a standard staging environment. And also, you may be required to do exploratory testing using configurations or test gateways that are not available in the normal staging environment. So you have to have multiple environments for that. And now the idea is that we want to provide the right test environment for each change that we do. For example, if we have a complex change, we want to do a load test for that. If you're writing a gateway implementation, you have to make sure that it works in a simulated environment first, if possible, or then you have to test it in production. You may want a playground environment for exploratory tests with different configuration than your normal staging environment. And also, we're going to talk about how we are able to test directly in production while minimizing the risks by using feature flags and canary deployments. And what you see here on the right is a bridge from my home country. It was built at the end of the 19th century. And of course, civil engineers back then didn't have computer simulation. So the way they tested the bridge, on the day they opened it, the chief engineer, together with his team, went on a boat under the bridge. And then they had a train running over the bridge. And fortunately, it held. But next time you have to deal with the load system, with a load test, at least be careful you're not a civil engineer. And the problem with load testing is that sometimes it's hard to define requirements for it. It's more difficult than doing functional testing. And in my experience, the best starting point with this is identify a few important key metrics for your system. Maybe it's about the requests you can handle per second, for example. And then do a few benchmarks at the beginning. You come up with a baseline, and then you're able to see in time whether your future load tests show you any decrease in performance. Because the least you want to do is just at least maintain your present performance of the system. Ideally, you would be able to run these performance tests periodically on your system, but that's going to be expensive because you probably want to run them on 100% of your production computing capacity. If you're lucky and your system behavior is linear, maybe you can come up with a load test that uses maybe 10% of your production computing capability and expect 10% performance from that. That might be an option for you. That's worth exploring. And it's also important that your load testing environment injects a degree of randomness into your tests, things like variable latency or a number of requests that will fail, and then you have to investigate how your system behaves under increased load and also increased number of failed requests. Also, now let's talk about testing in production. So what we have here is a simplified workflow that shows how we do our deployments at KOMOJU. Basically, for every new deployment, we have a set of smoke tests, we call them. They are E2E tests that run directly in the production environment. If any of these very important tests fail, then we roll back. So we throw away the new deployment, we start investigating. If the tests pass, and we have kind of, I think, a window of 15 minutes to run these tests, if the tests pass, then we begin a gradual rollout in which we expose only a fraction of our users, let's say 10%, to the new deployment, and then we monitor for errors. And if there's any anomaly, we automatically roll back to the old deployment and again start investigating. Otherwise, we continue with the new one. And what you see here is a synthetic test on Datadog. Basically, it's an E2E test. The only important thing about it is that it runs on this canary.komoju.com, which is basically the production environment we have. It's not accessible from outside, of course, because we want to be the first ones that try the new deployment. But it uses the production database, production services, everything, real money. Also here you see a screenshot from AWS Code Deploy. So after we run our smoke tests, we again have a 50-minute window in which only 10% of users use the new deployment, and then we monitor for errors. And if there's any anomaly again, we roll back. And now let's say we managed to do a deployment and everything is fine until this point. We still want to be able to increase our confidence in a feature before showing it to all of our users. So what we do, we use feature flags. Now, feature flags are kind of a double-edged sword because they increase they increase your code complexity. And if you think of a feature flag like a Boolean configuration, basically for every feature flag that you add to your code, you're going to have to double your number of test cases. The advantages is that it provides a fast way for us to revert at any time. So let's say we are doing either automatic or manual testing for the new feature, and we notice that there's a critical error in production. What we do, we disable the feature flag and we go back to the old safe code. We also have another type of, we call it global feature flag. Basically, it allows us to expose only a number of our users, maybe 5%, 25%, and so on, to the new feature. And then we are able to automatically and also manually monitor for anomalies. And we can do this for a day, a week, and so on until we have enough confidence that the new feature is stable enough to be used for all of our customers. Now let's talk about limitations of this approach. So we said we have different testing layers and different environments. The problem with this is that this is going to increase your testing time. So you want to be able to judge for each change, for each PR that you have to test, you have to judge whether to use all of the safety layers you see here or a part of them. And of course, if you do a complex change, you may want to use all of them. So to leverage all the testing environments you have. If you do a simple change, then you probably don't want to run a load test, which is very costly, and you probably don't want to add a feature flag for your simple change, because then you have to remove it later, and it's going to be a headache. And now, let's see how we can keep the testing time under control. So we all know mathematically it's possible to prove that you can test all the inputs of a system, all the code paths, and then all the outputs. Obviously, this is going to take a very, very, very long time, so it's impractical and it's almost never used. I think the magic of QA is to be able to identify the right risk scenarios for your feature, test those scenarios as much as possible until we reach that point of diminishing returns, and then release the change in production and do the real test, which is how your system behaves in the real world. And of course, it's easier said than done, identifying this point of diminishing returns. And it's often not only about the QA team trying to identify this point, it's about having the right communication between your QA, your developers, your SRE team to be able to find the right risk scenarios and to come up with solutions on how to mitigate those risk scenarios, so that if those scenarios occur in production, you'd be able to prepare in advance on how to deal with them. And I just want to mention two tools I'm using daily. I usually focus more on principles and frameworks because I think they age better than tools. But one of them is Allure. It's called Allure Report. One of the challenges that the QA engineer faces is sharing the test results with multiple stakeholders. So it's not only the QA team that has to consume the test results, of course, it's the developers, it's the PMs, and so on. And each member has like a different kind of information they want to see in those test reports. Maybe a developer is more interested in an error log and the actual code of the test. Maybe a project manager is more interested in a natural in the natural language steps of your test to understand how it affects how a bug affects a feature from a customer perspective. And Azure is able to do that. So basically you have one single source of truth that records everything about your test and makes it easier for developers to debug the test, to fix the issues, and to make everyone understand what the gravity of the failure is. Another tool is called Datadog. Basically, we use it for monitoring our application through tracing. We also use it to run our synthetic tests. And we have a number of monitors in production that allows us to see the key metrics of our system to notice if there's any anomalies. One of them, for example, just to give you an example, it's this. It's a graph with 3DS requests that fail. So basically, whenever a customer does a credit card payment, they have to input a password they get from the bank. And you see this spike here, the anomaly we have to investigate. It could be for a number of reasons. Maybe a lot of users genuinely got their password wrong, and those errors are genuine. Maybe there's a malicious actor that tries to test your system, so you may want to block that pretty fast. Or maybe you just merged a PR that modified this 3DS behavior in some way, and you broke it, and you couldn't predict that break. The idea is, when this kind of anomaly happens, we get an alert on Slack, and for each team has a member that's on call. So we are able to monitor this basically as fast as they come, and then go to Datadog, and multiple teams can collaborate. For example, maybe you have a QA team member, an SRE team member, a developer, and they can assess what the root cause of the issue is and whether we need to do something to mitigate the issue. And of course, no matter how many safety nets you have, how many environments, how many tests you do, you're going to encounter situations in production where you had issues. And I think the best mitigation strategy for that is to have a transparent workplace that allows you to basically gather people from multiple teams, QA team members, SRE, developers, project managers, so that they can analyze why a systemic failure happened, why all those safety nets got penetrated, and you had to face a production bug. And I think the key takeaways from this is that having multiple test environments can bridge the gap that there is between the staging environment and the production environment, and also that it's way more important to test the right risk scenarios than trying to have exhaustive coverage for your system. And also, last but not least, if you're passionate about any of the technologies you see here on the right, we are hiring at KOMOJU. You can check out our positions on tokyodev.com. So feel free to check them out. And that was pretty much it. Thank you for your attention.